be helpful if we turned on the audio. Good morning, everyone. Good morning. Good morning. Good evening. How are you doing? Happy Monday or Monday evening. Hopefully, work was or is going to go well. Exciting today. It's exciting. Mondays are always exciting. You want to know why? Because you get to set the pace for the week. Figure out what you're going to do, figure out how you're going to do it, and how you're going to get it done. That's the best part about Monday. I got my fresh cup of coffee, delicious, and super excited to talk about spatial computing. What that is, what that means, it's going to be a multi-day, multi-month process to get through all these technologies and make sure that you guys are aware, interested, and understand what is important. So that's great, right? That's really important. We're going to dive into head-mounted displays today. We're going to talk about what spatial computing is, how and what the market looks like, and a little bit of history as well. So if you got questions, if you got comments, throw them in the chat. Okay, if you're on Twitch or you're on YouTube, throw them in there. If you're on LinkedIn, post a comment. Happy to, have you be an active participant. If you're sending me messages on LinkedIn while I'm on live, I can't read them. So get in the chat. Make sure you follow us across socials. Again, for those of you who don't know, I am Rob Petrosino, futurist, emerging technology extraordinaire, an executive who focuses on educating others about technology and making sure your organization is prepared for the future. So if you're interested in technology, you're excited about it, or you want to develop it and launch it for your organization, or be seen as a thought leader, that's why you're here. With that, we are going to get into it today and head over to the screen share. So, what is spatial computing? It is quite easiest to define as the process and tools used to capture, process, and interact with 3D data. 3D data can be a misnomer here. Okay, that does not just mean data sets or point graphs or time analysis or things that you would put in a spreadsheet. Think of data as anything that's captured by a camera or a LiDAR sensor. For those of you who don't know what a LiDAR sensor is, that is quite simply a sensor that sends out radar sensor that's going to go find a pixel distance in space and return it back to the processing unit. So spatial computing is the tool and process to interact with 3D data. And 3D data can quite literally be anything. It could be a map, it could be an avatar, it could be a smart warehouse with IoT data. If you want to learn more about that example, head back a couple videos or head over on YouTube. We did a nice little presentation about digital twins that I think you will find interesting. So what we're saying here is that spatial computing is a process of interacting with that data. So if we think about these interactions, we need to be able to visualize them in some way, shape, or form. Okay, and that visualization can happen in two areas. Okay, that can happen in augmented reality, or it can happen in virtual reality. We are not here to discuss which one is better or which one is worse. We are only here to discuss the different between them and what units, headsets, head-mounted displays we'll talk about in a second here, what way you can visualize that. So augmented reality and virtual reality sit on the spatial computing spectrum. So AR, VR, MR, XR, extended reality as a term overall. It is a floating spectrum from left to right. And what that means is that there is some variance when it comes to experiences, but we can pretty much plot any experience or any device that unlocks these experiences on this graph. So augmented reality. That means, in the most simplest terms, I retain the understanding and visualization of the real world around me, and I'm adding data on top of it. Think of it as a simple heads-up display on a car. It's not very easy to do, but I'm showing my gauge on my mirror, or my window, excuse me. I'm showing the speedometer on my window. And as I drive, that number is changing depending on how fast I'm going. Very simple heads-up display. All the way on the other end of virtual reality is when you are actually in a virtual world. Okay, you put on a headset or you go into an experience and you are completely missing the real world around you. It is not existent at all. I put this on and I am on Mars or I am in Europe, etc. And I don't live there, right? I am completely embedded in this virtual world. It's important to draw a distinction between the two because all of the hardware and devices that are out there are starting to blend augmented and virtual reality together. That's why I say it's a sliding scale. Some devices are better at augmented reality, some devices are more suited for virtual reality, and there's this scale that slides between them. Now, every experience that gets built, you can also put onto this map, right? So, a very simple augmented reality experience is when I use my iPhone to make myself, or I use my Android phone, my smartphone, to make myself look like a puppy dog on Snapchat or Instagram or any one of those. That is an augmented reality experience that allows you to visualize yourself with digital information on top of you. That is pure augmented reality. Virtual reality, you typically need more hardware. We're going to talk about that a little bit here in head-mounted displays, but that's when I put on, an Oculus headset or PlayStation VR, and I'm completely immersed in a game. If you're on LinkedIn and you're getting buffering, because I'm seeing it, even though my stream health is excellent, come on over to Twitch or YouTube. It's going to be a much easier experience, much better. Links are in the bio. Feel free to come on over and check it out. So let's move on. What's a head-mounted display? Rob, you started chatting about this already. So a head-mounted display is something that you wear on your face, wear on your head, and it enables an AR or VR experience around you, an extended reality headset. Every major player underneath the sun is making some version of this. We will not speculate about what Apple's doing, but there's a lot of rumors out there. We'll save that for another video. But Meta, Magic Leap, another major brand, Pico, HTC, PlayStation, TCL. There is a lot of headsets that are out there, and they all sit on this kind of spectrum. A headset has a significant amount more sensors than what you're actually seeing on any of the other devices in the market. So your iPhone has 18, 19 sensors on it. A headset's going to have double that, sometimes triple that. It can do hand tracking, it can do eye tracking, it can perceive the real world and understand a table that's in front of you and what the plane is or walls, etc. So there's a lot that happens on the sensor side when it comes to head-mounted displays. The one thing to keep in mind is, and the most important thing to think through when you're going through an experience and you're not sure where it falls on the spatial computing spectrum is, can I see the real world around me? That's a very good indicator on whether you are more based on augmented reality or virtual reality. So that's that kind of sliding scale when we think through that. Again, if you have questions or anything like that, throw it in the chat. Very, very happy for you guys to be here and listening in. So, head-mounted displays have been around for decades. Okay, Nintendo had a virtual reality headset way back when, and there's been a lot of development since that. We're talking about decades ago. I think it released in the late or early 80s, and you could put this on, and you were able to play, and it was a consumer-ready device, which is pretty cool. So, when we think of head-mounted displays, it really is a tool to unlock AR or VR experiences. It is not the only tool, but is the most popular tool as it stands. What that looks like as far as a spectrum is very, very interesting. And we see some massive players in every part of the spectrum right now. So CES just happened a couple weeks ago, and we saw the launch of a couple different headsets that were interesting. So we're going to talk about most of these headsets and where they sit and why we put them in these specific areas on this Rob Petrosino's Headset Roundup XR spatial computing map. If you guys have comments, if you have questions, if you disagree, you think something should be somewhere else, let me know. One thing we will touch on briefly is tethered versus untethered devices, because we have to, but we will discuss this as it stands. And if you guys want to have pushback, that's cool with me. I'm all right with it. So, AR headsets. Typically, AR headsets are going to be lighter. Well, why is that, Rob? Because they don't need as much processing power to have an experience. Okay, well, that's because we don't have to render we don't have to render the real world out of view. Okay, so I don't have to see, that virtual setting. I can use the real world as my quote unquote background. So, the headset on the far left here is the TCL headset. And what that does is it allows you to put on a headset and have basically a heads-up display in front of you. Pretty interesting. Really, really nice when we think about what that looks like, and just came out at CES. So obviously with the clear glass, it's a little bit bulkier, but that's okay. With the clear glass, it actually lets you retain the real world around you and continue to add or augment it with digital information. Next up is the Nreal glasses. These Nreal glasses are pretty interesting. I put them on the augmented reality side for a reason. For anyone that's super familiar with Nreal, you could say it also can go on the virtual reality side, but for certain instances, I put it here. The Nreal glasses actually plug into any USB-C port, so if you have an iPad, you can actually plug this in directly, and it does screen mirroring, but through a clear set of glasses. So I can actually have my desktop 110 inches wide in front of me while I'm working, if I wanted to, or plug it into my phone and put it on and watch a movie or something along those lines. And instead of watching it on the tinier screen, it blows up to real size. There is, for those who took the 202 spatial computing class, the Nreal device actually has a clip-on that clips onto the front of the glasses that blocks out the real world. It's just a piece of plastic that fits over the glass, so that's why some people say that it might be virtual reality. Next up is the Magic Leap 2 headset. This is probably one of the most impressive XR headsets that are out there. It is phenomenal when it comes to power, compute, etc. As we said, these first two are very interesting, but the Magic Leap 2 starts to blend in and pull in more interactivity that you couldn't do on some of these other ones. Built-in hand tracking, LiDAR sensors. It takes what the lack of sensors that you have on the first two here and starts to add in spatial audio, two-way video. Cloud computing, Wi-Fi detection. Doesn't need to plug into a phone or another device. It is standalone, which is pretty impressive as well. Me, myself, and my team have built several applications that deploy in ML2, and between the controller, the compute pack, the visualization of the glasses, it's very, very impressive to say the least. What's also really interesting is that these glasses themselves, the glass on these can be electronically dimmed. So think about the old polarizing lenses that you would have when you walked outside in the sunlight. You can now do that electronically, where you have a little slider. It's called global dimming. I can pull that all the way up, and it'll actually dim the glass and make it dark, which is pretty cool. Which ultimately, I can make it as dark as very, very dark sunglasses, and which increases the visual fidelity of the information that's in front of you, whether it's flat information or whether it's a 3D model or map experience. It's really starting to blend that virtual and augmented reality. It takes the Nreal clip-on sunglasses to the next level and does it electronically. Dead set in the middle here is the Vario headset. This is the XR3, I believe. I know the Vario team very well, just like the Magic Leap team, and their headset is incredibly impressive. And it is a true mix between AR and VR. And the reason for that is because it allows you to use these 4K cameras that are on the outside of the headset and see the real world, and then pass it through into a screen that's in front of your face. It does this through tethering to like a high-end computer. We weren't going to get into that, but the really interesting thing is that I can blend virtual and augmented reality. So they have a ton of videos out of someone when they put on a headset, they can see a driving dashboard in front of them. So they can see a steering wheel, they can see various buttons, they can even see their hands, and it's all clipped out. Okay, so that it's real time or near real time feedback on the hands that they're driving, but everything else above the experience, right? Everything else is VR. So I had this tactile response of holding a steering wheel and driving, but when I look out, I'm driving in the Swiss Alps instead of sitting behind my computer screen. That's really interesting when it comes to this blend of virtual versus augmented reality. To the right of that is the MetaQuest Pro 2. Again, same type of camera pass through, but definitely more geared towards VR than augmented reality. Quite admittedly, the headset has not the best cameras on the front of it, and the pass-through experience is far from optimal if you needed to read something or do anything. However, they do have that color pass-through option, just like Vario, with a little bit more latency because it's just a head unit. It doesn't tether into something, and it's really built to have this type of gaming experience where I put on a headset and I can virtualize things and I'm in VR, but then I can switch it and go into pass-through AR where I'm using those cameras and have it for like a workstation with multiple screens and that type of thing while I'm working. So a little bit more towards the VR side than the AR side, but still not as far as the Oculus. So the Oculus over here had pass-through technology as well, but it was black and white pass-through. So what that actually did was allow you to only see the real world around you when you stepped out of the playgrounds, right? The sphere that you would draw, or the circle that you would draw, so that you knew where you were. It would go black and white. Now there has been some interesting tinkering that's happened there to change what it looks like, but as far as the pass-through, but it is really a virtual reality first device. And then you have the new PlayStation device as well, has more cameras on the front end than the Oculus, but still geared towards VR. And the reason for this, as you look at the spectrum, you're going to see that most of the VR devices are direct-to-consumer focused. Most of the middle the leaning towards augmented reality, higher compute power, so the Vario and Magic Leap are a little bit more enterprise, and then you go back down to direct-to-consumer market on the left-hand side with the TCL and Nreal. To give you like rough price points, the Nreal Air glasses that we're talking about here are about $300. The Vario headset is over $5K. An Oculus is again $300 to $500. The Magic Leap is more of an enterprise device, being around over $3,000, and then the MetaQuest Pro 2 is over that $1,000 mark. So this is what we're talking about when we think of this headset spectrum and unlocking AR and VR headsets as an enablement tool for spatial computing. So what that gives us is a quick overview of AR versus VR, the spatial computing spectrum, and where headsets align to that spectrum to make it more interesting. That is all for today. This is going to be a lot of unpacking. We have to dig into pass-through tech a little bit more. We have to dig in what type of experience that you see, what the visualizations are, what the fidelity is. But this is a really good starting ground if you're interested in this technology to do a little bit more research. But if you have questions, if you're interested, if you have concerns, always reach out to me and let me know. Super excited to have you here. Again, I'm Rob Petrosino, Synth Reality Podcast. Follow me on the socials, and don't forget to reach out. Always excited to chat with you. Have a good one.